In today's lesson, we're going to look at another algorithm that uses recursion to solve another math problem. Once again, we'll write a non-recursive solution and then see how to convert it so that the same problem can be solved using recursion. First, let's describe the problem. So, in math, a number can be broken down into its factors by figuring out what numbers could be multiplied to create that number. So if I have the number 8, its factors could be said to be 2 and 4, or 2, 2, and 2. And if I am trying to find its prime factors, then 2 and 4 are not acceptable answers, but 2, 2, and 2, which does equal 8, are its prime factors. Let's take another number as an example and factor it, or come up with its prime factors. If I take the number of 12 and I divide it by 2, I get 6. So 2 is my first factor, and I have 6 left. 6 is not a prime number, so I'm going to figure out the factors for 6. Well, 6 can be expressed as 2 times 3. So now I have taken the number 12 and expressed it using prime factors. We're going to write an algorithm that will output the prime factors for any number. It's worth noting that some numbers, like 13, have only one factor, the number itself, which defines them as being prime numbers. Okay, let's now look at the code. So we'll begin by creating a new Java project which we'll call RecursionMorePractice. And then within our new project, we will add a new class, and let's call this prime factors. It will have a public static void main method, so we'll check that box, delete the unnecessary comments, go ahead and put your name in the file, and then we're ready to begin. Now, for this first version, all we're going to try to do is to output to the console the prime factors of a number. So, first we need to create our method. Our method will use the keywords public static, and because it's not going to return any value, its return type is void, and let's call it prime factors, and its argument or parameter will be one integer variable, which is the number that we're trying to calculate the prime factors for. Now we're ready to begin writing our code. So, how are we going to find the prime factors? Well, as you saw from this simple examples that we did in Microsoft Word, so let's go back and put one in. If we're finding the prime factor for 6, we start by determining if 6 can be divided by 2 evenly. And so that means our first potential prime factor is going to have the value 2. And I'm going to create a variable to hold that. I'll call it possible factor, because that's what it is. And then I want to find out if, in fact, this possible factor is a factor for number. Well, if number can be divided by possible factor such that the remainder value, which is what the modulus operator does, it divides these two numbers but gives us the remainder, is exactly 0, then that number is evenly divisible by possible factor, which means that we found an actual factor to our number. And if that's the case, what we want to do is output that to the console. So we'll print our possible factor, which we can now say within this if statement actually is a factor. Now, if that were all it took, we would be done. But of course, we're not done. what do we have left to do? Well, we took the number 6 and we said that we found a factor of 2, and that leaves 6 having the value 3. 6 divided by 2 equals 3. So what we want to do now is say that the new number that we have to find the next factor for is equal to our current number divided by our possible factor. Okay, so the question is, what happens if we reach our next number, 3, and it's not evenly divisible by 2? So if the number here were 2, or rather 3, and our possible factor was 2, it's not evenly divisible. Well, what would we do? We would first trap that case by writing an else statement, and then we would need to determine what's going to happen next. Well, if 3 is not evenly divisible by 2, then we need to see if it's evenly divisible by the next number up. Let's see. How would we increase the number that we want to be our next possible factor? Well, we can just say possible factor should increase by 1. But our little program here has ended. What do we do to make the whole process loop back so that we can keep going? Well, we could do that using a while loop. What's our while loop going to say? Well, we want to keep going as long as possible factor has a value less than or equal to the number that we're looking for. So possible factor will increase, and if possible factor ever reaches a value equal to the number that we're looking at, then that is in fact its largest possible factor. So 13 is a good example. If we were looking for factors of 13, we would start by seeing if it's evenly divisible by 2. It's not, so then we would check 3. Not evenly divisible, 4, and so on, until we get to, let's stop at 11. Then, is 13 evenly divisible by 12? No. Is it evenly divisible by 13? Oh, yes, it is. So, we will be done looking at numbers. Our while loop will end. But we're not quite done yet, because we have a couple other things we have to worry about. Well, one is, it would be nice if between our numbers that we're outputting, we output some nice multiplication symbols. So like if we were doing the number 8, we would want to see 2 times 2 times 2 as our factors. And if it was 6, we would want to see 2 times 3. And if it were 9, we would want to see 3 times 3. We want to get the times symbol in there. Well, how can we do that? We could just print it right in here, system.out.print, and put an X in there. However, if we run this right now, you'll see that this creates a minor problem, which we'll have to deal with. And we'll get to that in a moment. So, let's test our program and see what we get. Prime factor, let's start with a simple one. Let's go with 6. And, oh, it's prime factors. Okay, let's run it. And as you can see, we got 2 times 3, but look, we have a times at the end here. How can we make it so that this times symbol only prints if there's still more factors to go? Well, after we've divided number by the possible factor, if the value we're left with is exactly equal to 1, then we're done factoring. So we could say, if number is not equal to 1, then output our X. Okay, let's run it again. And we got 2 times 3. Let's pick a more interesting number. How about 27? 27 gave us 333. How about 28? Here we calculated the factors of 28 as being 2, 2, and 7. 2 times 2 is 4. 4 times 7 is 28. What are the factors of 29? Well, there are no factors other than 29, which tells us that 29 is a prime number. Let's try 120 and see what we get. 2 times 2 times 2 times 3 times 5. It sure looks like our prime factor solution is working. Okay, so we've now written an algorithm that finds all the prime factors for any positive integer. Now, let's look at how we could write the same code as a recursive method. So, we are going to also start with public static void prime factors are as our name, and it will take number as an argument. Good. Now we're ready to begin calculating our factors. Well, when we're writing a recursive method, the very first thing we need to always remember is that we have to watch out for the base case. So, what is our base case in this case, in this situation? Well, if we get back down to a situation where number has a value exactly equal to 1, then we have factored this number completely, in which case we want to return. If that's not the case, then we need to do something. Well, what do we need to do? We need to take number and we need to look for its next largest factor. But do we have any way of knowing what the current factor is? So far, we don't have a variable for that. So the first thing we need to do is add another parameter, which is going to be our parameter for keeping track of our possible factor. Okay, so what do we want to do? Well, the first thing we want to do is look for the next possible factor, which will be possible factor, its next value, so we increase it by 1. And then we're going to want to figure out if it's evenly divisible by that factor. So if number is evenly divisible by possible factor, which is another way of saying number modulus possible factor is equal to 0, then we have a situation where we found a factor. So let's print the factor. And then, just like we did above, we now need to move on to finding our next factor. But unlike our traditionally coded looped version, how do we move on to the next step without using a traditional loop? Well, we simply call prime factors are again, only this time the number we give it is equal to the current number divided by the current possible factor, and we also give it the next new possible factor to look at, which in this case would be the number 1, because the first thing that our method does is increase the possible factor by 1 to go on to the next possible factor. So this will trigger a recursion within our loop. But what do we do if we don't have a factor? Well, that's our else state. We call prime factors are with the current number and with our current possible factor, because in that case the next recursive call will increase our possible factor by 1 and see if that number is divisible evenly. If it's not, then the process will continue. Okay, now, if we want to put our multiplication symbols in here somewhere, we sort of have to decide where we're going to put them. So, we might want to do it right here by saying, if number divided by possible factor is not equal to 1, then let's output our x. Okay, so we're now ready to begin triggering our prime factors r. But unlike our first version here, we have to actually give it a initial possible factor, which should always be 1. So let's run it, and look at that. We got the same exact answer, which implies that our code is working. Let's try it for a prime number and see if we get 7. We did. Let's try it with 6 and see if we get 2 times 3. Perfect. Let's try it with, how about 14? The prime factors should be 2 and 7. Very good. It seems to be working. Okay, so this is a prime factor solver method using recursion. However, this does introduce one other interesting aspect of using recursive methods. What if in the main program I pass this a bad value here, like 3? Interestingly enough, it still gave me the right answer, only out of order. And what this introduces is the idea that a person or another programmer using my prime factors method, because they are allowed to put in the initial value here, can change the way my algorithm works. Traditionally, we protect our algorithms by actually having a shell around them. So what I would do is write another method declaration called prime factors r that only takes the number as an argument, and then I would rename this and change it to private, although in this instance, the way we've written that, it won't actually change anything, but it's good practice. Then prime factors r would be renamed with some other name, recursive, let's give it a longer name. And what does prime factors r do? All it does is calls prime factors recursive with number and 1. This does two things. One is I can now use either the recursive version or the non-recursive version using the same number of parameters, and they both give the same result. This also means that there's no way that I can mess up the recursive solution by putting the wrong value in. And by making this, we need to change this to recursive, so it has the correct name when calling itself. This also means that if I move this code into a separate method, so for example, I want to turn this nice recursive prime factor solution into an actual library. So let's go through the process of doing that. First, that means it won't have a main method. Secondly, let's eliminate our non-recursive solution. And now that means that we could just call this prime factors. And we're now set up. Now the fact that this is private means that if I have a new driver class, so I will create a new class that actually has a main method. Let's call this test prime factors. Give it a public static void main, and I want to print out the prime factors of my number 145. Run it, and you can see that we get 5 times 29. Now, the important distinction here, and the important thing to note, is that this method is private. Therefore, within my main method, when I type prime factors dot, notice that there's only one method listed there that's available to me. So I select that, and I can now fill it in with any value, and my code works. Excellent. So we've now written a method which will output to the console my prime factors. But of course we know that it is bad form to have a method that's not in your own main output values to the console, because the programmer has no control over what happens to those values, and they may want to process that value in some way. So, if we're being a polite programmer, what we actually want our prime factors to do is to return a string value. So private static string prime factors. Now, I'm getting an error because I cannot have two methods that return different variables. What you need to do for the next assignment is rewrite the prime factors method so it returns a string value, which means you'll also have to rewrite the prime factors recursive method to return a string value. So this method should simply return the value of this method, which should return a value. But right now, of course, we're not returning anything. That means that we're going to strip out, or you're going to strip out all of these system outs and modify the code so that it in fact returns a string. I'll give you a hint. It's going to require that you modify your method here to include another variable, which is going to be a string of the prime factors that you've calculated so far. And of course, in your return value, you're going to need to return the string, which should be the prime factors. That also means that along the way, these other methods are going to need to return some values. So you're going to say that the current prime factors are equal to the prime factors recursive with the factors that you've calculated so far going in, and the prime factors here also being equal to the prime factors that you've calculated so far. And then the method is ultimately going to return prime factors. Except this should be in the situation where we have detected that we've found our last prime factor. So let's see. We're going to want to put this exactly where? We're going to put this right after here. We need to have a return in each block of the if. So here we're returning prime factor, and then in the else we need to also return prime factor, or prime factors rather. Okay, and when you make your initial call to prime factors recursive, you'll start with an empty string. This should give you the basic code. With a few modifications, you should now be able to finish this out so that in my main method, I can do system out println the prime factors of plus, and then let's create a variable r test prime factors dot prime factors of number. And we need to figure out why we're getting an error. Okay, let's see. Oh, we're missing a parentheses. There we go. Okay, so if I run this program, once you're done, instead of getting the output of blank here and my 2 times 2 times 3 times 5 here, I should get that answer here at the end. Because right now the code is spitting out this information directly to the console, and you need to modify it so that the variable gets returned in prime factors. That should not be too difficult at this stage. Give it a try, see what you can do.